Hello friends, how are you guys? And my name is Subham Sharma and I'm going to teach you today mensuration. So mensuration is nothing but the part of mathematics which deals about the volume of certain figures, surface area and etc. So that it deal with these things. So to get into the mensuration, I'll just draw one figure. Some of you might have seen this figure and some of you not. So let's look into that figure. So this figure look like this. I hope some of you have recognized it is nothing but a cuboid. And cuboid is nothing but it is an extended version of a rectangle. You might have seen this figure, right? This is nothing but a rectangle which has a length L and which has a breadth which is B, and same way this cuboid also has length, breadth, as well as it has height also. Okay, so this is, can you recognize the difference between these two figures? This figure is a 2D figure and this is a 3D figure. How I am telling that this is the 2D figure and 3D figure? There are different ways to recognize that. Simply it has 3 dimensions, right? How? Length, breadth and height, and it has only length and breadth, right? And it has, it may have planes also. 3D figure have plane but 2D figure don't have any plane. 2D figure are straight simple figure like rectangle, triangles. If I'll draw like this figure, this is a triangle, so this is a 2D figure. And same way extended if I'll draw the 3D figure of this triangle, so extended version of it will be a pyramid like this structure. So this will be an pyramid, right? Triangular pyramid it will, we can call it as. So this will become a 3D figure. It is nothing but an extended version of a triangle, right? So now let's come to this topic. If I'll just say area of this rectangle is length into breadth. Now you may ask, like, why you simply wrote length into breadth, how it came? So I'll just explain why. Some of you might know, some of you don't, so let's learn it. So if I'll just draw one line over here, let's suppose I drawn one line, or just I took a stick and I just kept here. Again I took a one more stick and again I put on this. Again I took a stick and put on this, and I gradually I came to know that by putting so many sticks or some sticks, I just came to know that I have made a such structure, right? And I just call it as length L because it has some it has some breadth, so it will be breadth B, and this will be length L, and it has same length of all the sticks are same, and breadth is also same, that is gradually increasing, so I just denote it as by B. So the area is nothing but the region occupied by the particular thing, right? So region occupied by these sticks will be this one, and this one is nothing but the length cross breadth. So this is how we will get the area of a rectangle. And if you consider about the units, so unit of length here, if I will give in meter, and here breadth in meter, so meter into meter, we come to know that area unit will be meter square. I hope you got it. Same way you can see here, this cuboid also has this front face, it's look like a rectangle only, right? Isn't it? And if you think in the same way at the back figure, the back one will be looking the same way. Side, these two side also look like a rectangle, top and bottom also will look like a rectangle. For an example, if I'll take an example, see, this is another smartphone. Okay, so just consider it these as our sharp edges. So this smartphone having this upper surface and the below one and the side one and another side and this side as well as this side. So it has totally how many faces? 6 faces it will be, and in that the upper faces and the bottom faces, both the side faces and both the edge faces are equal. These two faces are equal, these two faces are equal, and the up and down are equal. In the same way, if I'll calculate the area of this figure, see, I just name it 1 and the back one is 1 dash. If this is 2, this will be 2 dash, and this will be 3 and 3, and the upper one will be 3 dash. And the area, if I just want to calculate this total surface area of this particular figure, how will we be calculating? So total TSA, total surface area of this particular figure, how will we be calculating? 1 plus 1 dash plus 2 plus 2 dash plus 3 plus 3 dash, right? And why I gave name 1 or 1 dash? Because these two are look like similar only, right? So this face and this face both are similar only. It has length as well as the height. So what will be the area of this number 1 face? It has length and it has got height. So it is nothing but length into height, right? And the same way the back face, it also has same length as well as height. So again, length into height. When we come to this side is what? Breadth into height. So it is breadth into height. For this face, again it is breadth into height. For the bottom and top is length into breadth. So it is nothing but length into breadth plus length into breadth. See, there are two things are common, so I can rewrite it as 2LH 2BH plus 2LB. So I can write it in this way: 2LH plus 2BH plus LB. 2 I'll take common outside, and in books don't get nervous by that or excited by that in books you will find like this: 2LB plus BH plus HL. You will find like this. If you write this way or this way, both are same. So this is how we used to calculate the area of an cuboid, right? Okay, so again, if you want to calculate the unit of this thing, so again you see here length and breadth are multiplying, so unit is meter square. Again here meter square, here also meter square. So you will take a common unit only, right? Again it's a multiple thing, right? So finally the total surface area unit will be in the meter square only. I hope you got it. Okay, and now we'll be calculating its volume. Volume is nothing but how much space it is occupying. See, let's suppose if you have a cartoon at your home, so the cartoon will look like cartoon in the sense, or if I'll say a box, that maybe it's a TV box, or maybe it is your computer box, will be look like this only, and it will be packed in this. Your computer or your TV will be packed in your either your LCD will be packed in such kind of box only, or we can say in cartoon, or maybe there are some other figures that look like the same thing only. So it is not it is same like the cuboidal figure, right? So when we talk about the volume is nothing but how much space is occupying. Let's suppose you have a water bottle of 1 liter, or say this is a water bottle you have in a water bottle, right? See, or this is a jar, or you can consider it, yeah, this is a jar which it contains 1 liter of water bottle, 1 liter of water, right? So what will be the volume? The space which it is occupying. How much space it is occupying? 1 liter. 1 liter, or liter we can convert into the meter cube also, right? So we can convert into the meter cube also, or either the liter. So how much space is occupying? That is nothing but the volume. Same way, how much space this cuboidal shape is containing is nothing but the volume of this particular figure. And how we will get to know that how much space it will be, it will occupy? By its dimension, length, breadth and height. We can measure by the length, breadth and height, we can tell that this much of space this box can occupy, right? So what we'll do, we just multiply length, breadth and height, and if each unit is in meter, meter and meter, so finally if you multiply these three things, it will be in meter cube, right? So suppose that for a company, LCD manufacturing company or LED manufacturing company is, they required a box for to pack their TV. So what they will do, they will give the dimension of length, breadth and height of their TV. So according to that, the box manufacturer will manufacture the TV by giving some tolerance so that it will easily fit in that particular box. I hope you got it about this, how we used to calculate the volume. So if you have length, breadth and height, you can calculate the volume, and I gave an idea about the volume also. Now to calculate the diagonal of the cuboid, so what we'll do, again I'll draw the figure. I'll draw the figure over here like this, okay, to make you understand about the diagonal. Okay, I hope you got it. So for the diagonal, it will be like this. Can you see this figure and can you tell some more examples? Like, I think so you are sitting in a room, just look around your room and see whether it is in rectangular shape or not. The same thing only, the topmost corner and the lowermost corner, if you join these two, it will become your diagonal, right? In the room in which you are sitting, there also you can check, right? So to get this, we need to do some geometry things. What? First we need to calculate this one, then only we can calculate, because if we calculate this here, again it will become a right angle triangle, and we can use Pythagoras theorem and we can get the diagonal of it. And let's see how we'll do it. This is the, again, length, this is the breadth of this cuboid, and this is the height of this cuboid. Okay, so again this is again right angle triangle. So how we will calculate? Again we will apply the Pythagoras theorem. This is the length and this is the this is the length and this is again breadth. So length and breadth are here. So, and this is the hypotenuse, this is here at 90 degree, right? And when we talk about the rectangle, all the angles are rectangles are at 90 degree. These are straight at 90 degree and opposite sides are equal, right? Next, come to the point. So I'll just name it A, B, C, D, right? I'll just name this part E, F, right? E, F and G. I'll just name the whole thing, right? So I'll just consider as of now triangle A, B, C. Okay, so in ABC I need to get AC, which is nothing but the hypotenuse. So it is AC square equals to AB square plus BC square. So AC square is AB is L square plus BC is B square, right? So AC will be L square plus B square under root. I hope you got it. So this will be L square plus B square. Again, now I will consider triangle. This is the sign of a triangle. So triangle ACD. In the triangle ACD, I will consider now AD square is equal to AC square plus CD square. I hope you all know about the Pythagoras theorem because you have learned in the previous classes. And if it is not, so it is the right angle at C. It is C is 90 degree, right? So it is right angle at C see is 90 degree. So we just say this is the height, this is the base, and this will be the hypotenuse. So as we know that Pythagoras theorem says that hypotenuse square, if you don't know, hypotenuse square equals to base square plus height square. Either its statement says that the sum of square of two sides will be equal to the third side. Okay, now AD square. So to get the AD square we need AC square. AC square is nothing but L square B square, L square B square under root square plus CD will be, it is nothing but the height. CD is nothing but the height, right? So this is the height only, so I'll write here H square. So AD square will be, so now it is under root. So under root I can write it as L square B square power half and whole square. If power of power is there, then both will multiply according to the rule of power and exponent, right? For your explanation, I hope you might know these things. L square B square half into 2. If not, then I'll here to tell you. So 2 will get cancelled out, and AD square will be L square plus B square plus here H square, and finally AD will be L square plus B square plus H square under root. So here we get our diagonal over here, L square B square plus H square. This is how we used to get the diagonal of an cuboid. Same way we can get the diagonal of an rectangle also. How? Again here the same thing only, like we did it here on. How we can get for the rectangle? See, this is the rectangle, it has length, it has breadth, right? And it is, as I told you, according to the property of rectangle, that each angle of a rectangle is at 90 degree. If it is 90 degree, so according to the Pythagoras theorem says, if one angle is 90, then the sum of square of two side will be equal to the square of the third side. So we can say that hypotenuse, again the same thing, square equal to base square plus height square. So hypotenuse is nothing but, if I'll just name it A, B, C, D. So in triangle BDC, BD equals to BD square equal to CD square plus BC square, which is nothing but B square, CD, which is L square plus B square. So BD square, and BD is equal to L square plus B square, right? So here we got the diagonal for the rectangle also. See here we have two things only, and here we have three things, because it is a 3D figure and this one is the 2D figure. So we got the 2 dimensions only, because it's a 2D plane figure. So this is how we have learned about how we can get the total surface area of an cuboid, right? And total, then volume of an cuboid. Then finally we have learned about how we can get the diagonal of the cuboid. Same way, there is nothing in difference. Like same way we can get the total surface area, like directly we can get for the cube. Cube is nothing but, it is most likely similar to the square. I hope you all might know the properties of square. Square is all the sides are equal, all the angles are at 90 degree, right? If all the sides are equal, see this is an square. See, suppose this is a square, so area will be, it is the same. It's look like a rectangle, but it is not a rectangle because it differ from the properties. If you calculate the area, the formula will be same, length into breadth, but here length and breadth are same. Here length is also A and breadth is as, let's suppose A. So area will be what? A square, right? Again, so this is, cube is nothing but extended form of what? Square. Sorry, this is an square, right? This is square. So cube is nothing but an extended form of a square only. Cube is nothing but a extended form of a square. So if you get the total surface area, so what we will